Hello everyone, my name is Anjay, creator of a game called Chinchilla Run and co-creator of a game called Glitch Dash, and welcome to the first tutorial in what I hope to be a complete series of Unity tutorials that will take you from being a complete beginner to someone who won't necessarily know everything, but will have all the tools needed to start making your own games, do your own research, and solve your own bugs. Let's get started, but first make sure you smash that subscribe button for more content, and leave a like if you enjoyed the video. So this is what you should see when you first open Unity. Now, a lot of these windows can be confusing at first, so I'll try to explain each one. This is the scene editor where you can see the game scene in 3D or in 2D if that's what you're making, and where you'll place all the objects like this light and this camera that will go into your scene. Over here is the game view where you'll actually see what the player will see in game. Over here is your project folder, and this will store all the files and resources that you need for your project. Down here is the console, which will help you debug or figure out what's wrong with your code. And over here is what's called the inspector, and we'll be focusing a lot on this later on today. Essentially, the essence of game development in Unity is creating what's called game objects and giving them various components that will change their behaviors. To see what I mean, go over here where it says game object, and then you'll see a whole bunch of things. Go to where it says 3D object, and let's just create a cube. Now, if we look in the inspector over here, we can see a whole bunch of different stuff popped up. I'll try to explain what all these mean so we can take a look at actually interacting with all of them while we're doing programming. Alright, so we have our cube game object. Now, every single game object in Unity has to have certain components, which, as I mentioned earlier, essentially represent the different properties that they have or behaviors that they can do. The first component that every single game object has to have is the transform. This is the position, rotation, and scale of the object. Think of it literally as just the coordinates. It doesn't tell you anything about what the object looks like or how it should collide. It only shows you the position, rotation, and scale, which we can then change if we want the object to move around. Then there's the mesh renderer, and some of this might look differently for you, don't worry about that, but essentially it's the visual representation of our 3D object in game. If we didn't have a mesh renderer, we couldn't see our cube at all. It would just look completely invisible. Down here is the material. This is just kind of how the surface should look, so in this case it's gray. Then we have something called the box collider, which in this case it will tell us how the cube should collide. We can add tons of different components to this object. We can add something called a rigid body, which will allow it to interact with physics and gravity. We can add particle effects or sounds, but most importantly, we can add our own custom scripts. And scripts essentially allow us to program our game and make our game objects actually do stuff. So now that we have all this information that our components contain, our scripts can access that information and mess around with it depending on what happens. For example, we can make our player move around if the player presses certain keys on the keyboard. Let's take a look at how that works. So let's go over here to the project folder, and as you can see here, I created a script already called tutorial script. I'm just going to show you how to do that. I'm going to delete this. So I'm just going to right click, and you should see a drop down menu. Go to create, and at the top, C# script, and I'm just going to call it tutorial script. You can call it whatever you want. And then when I double click it, it should open up a new program called Visual Studio. So now we're here in Visual Studio, and a lot of this can look pretty confusing, but it's actually quite simple. If you know how to program, you can skip most of this. So up here, this is just what C#, the programming language you're using, will need to work with Unity. This class here is just going to be essentially the name of this file. You have to make sure that where it says tutorial script, that has to be the same as the name of your file. Here, :mono behavior, this just represents that C# needs to work with mono behavior to work with Unity. These curly brackets mean that we're making a section or a block of code, so this whole thing is the class. I can minimize that. These are also their own blocks of code. The void start and void update are the two main functions that are going to be called by Unity. Start is going to be called by Unity for every single game object that has one, or for every single script that has one on every single game object when the game begins. Update is called all the time, every frame essentially, so it kind of works like a loop. It's going to be called over and over and over again. So now, we know that our object has different components. In our example, I mentioned we can make a player move if he presses keys on the keyboard, right? So our script is going to have to hold on to that information somewhere while the game runs. It's going to need to know about the position value, and we're probably going to want a speed value for the player to move faster or slower. So to hold that information, we need something called variables. Variables are just that elements of code that will hold information. We can call these variables whatever we want, but we have to remember that when we use them, we're actually using the information that they're storing, not the name itself. From my experience teaching people how to program, they sometimes get that confused. So remember, when you write the name of a variable, you're talking about its value, not its name. The program doesn't care about the name, it only cares about what's in it. So first of all, let's give our player some kind of speed value. We need to declare a variable for that. To do that, we're just going to write, first of all, public or private. If we want to make this accessible from outside of the script, for example in the inspector, we have to make it public. Then we give it a value type. So in this case, we're going to want to make it a float. Now, a float is just a decimal number. You could also make it an int for integer, and you would write that here, or a string if you want to make it a word, but we want to keep that a float. And then we can give it a name. So let's just call it speed, and to end the statement, we just write a semicolon. The program has to know that the instruction is done. We'll give it a value later, so we won't worry about the start function for now, but over here in the update function, we need to check if the player is pressing a key on the keyboard, and if he is, we will change his position. So to do that, we need to write what's called an if statement, which is very simple. Just write if and then brackets for the condition. And then we have these curly brackets, which, as I said before, represent a block of code. So essentially, whatever expression inside of the brackets is true, whatever is in the block will run. So if I wrote, for example, something like 10 is greater than 2 up here, then this would always run because 10 is always going to be greater than 2. But we want to check if the player is pressing a key. So to do that in Unity, you have to access the input class. So we're just going to type input, and input has a function in it called get key. So we're going to call that, and the brackets there, you need to say W. So this is just how you see if the player is pressing W in Unity. When the player is pressing W, this function will return true. If he is not, it will return false. So now in the if statement block, we need to actually update the transform. Now, the transform component is special in that we can access it directly, but other components you need to call a function called getComponent, which we'll talk about in later tutorials. But in this case, we're just doing the transform, so let's write transform.position equals. So now Unity knows that we're going to be changing the transform position. Now, when I write transform like this with a lowercase t, Unity knows that I'm talking about whatever object this script is attached to, it's transform. So not some other transform or not transform in general, but the specific transform that belongs to this object. And then this dot position means that transform's position, and position is just the coordinates. We'll set this equal to a new vector 3. Remember your semicolon. Now, this position variable is a vector 3, and a vector 3 is just some data that has 3 floats in it. So it's a special type of variable. It's not an int or a float. It's something called an object, which has 3 floats, and a bunch of math functions that are very useful. So vector 3 takes 3 parameters. Since we only want to move our guy forward, we need to change the third parameter, which is the z value. So for x, we can just set that equal to our old transform position's x by typing transform.position.x. We'll do the same thing for the y, and then now for the z, or z, we want to change that. So we are going to take the old one, but then we're going to add our speed value to it. Now, if we just made these 0, 0 like this, then we would just teleport the player to 0, 0, and then whatever speed is, essentially. To actually move him, we need to add it to whatever it used to be. All right, so back in Unity, let's select our cube by clicking on it, and we'll take our script and just drag it. You can either drag it onto him like this, or you could have also just put it down here in the inspector, but now I have 2, so I'll just right click on that and then click remove component. And you see our speed value right here is visible because we made it public. So let's set that to something like, I don't know, 3 for now. You might need to make it faster or slower. And now when I hit play up here, this triangle, we can test it. And you see, for me, the cube just goes shooting off into the distance. Awesome. Alright, so now your job is to take that script that we just made and make the player move backwards, left, right, in the same way when he presses A, S, or D. I'll give you a hint. Change the X coordinate for A and D. You might want to also try subtracting his position by speed for certain keys. Try to see if you can figure out how to do that. Pause the video, and then when you're done, check to see how I did it. Before you do, let me just show you what happens if I spell something wrong in my program. So instead of saying transform.position, I'll just say transform. What if I forget position and just write transform? So you see the Unity console will tell me on what line things are going wrong, but it won't tell you if your logic is wrong, so you'll have to do a lot of trial and error, but I'm sure you can do it. Alright, now go ahead and pause the video and give your project a shot. I'll put the instructions up on the screen right now, and when you're ready, press play and I'll show you how it's done. Alright, so here's how I did it. Take a look. Try to figure out the code. I'm not going to be posting it in the description. If you made a mistake somewhere, I want you to try to figure out why it went wrong. Anyways, if you made it this far, congratulations. You should be well on your way to learning how to make games. Check out some of my vlogs, leave a like, and hit that subscribe button for more content. See you next time.